Question number 2, part A. Define velocity. So, velocity is the change in displacement by change in time. So, velocity is a change in displacement per unit time or change in displacement divided by change in time. Then a student throws a ball over a vertical wall of height h meter. So the height of the wall is h. This is h. So the height of the wall is h as shown in figure 2.1. The ball leaves the hand of the student at a height of 1.2 meter above the horizontal ground. So the ball leaves from a height of 1.2 meter. Then the ball has an initial velocity of 22 meter per second at an angle of 40 degree to the horizontal. So the ball has an initial velocity of 22 meter per second, at an angle of 40 degree. So since we have given the value of velocity, so by using this we can find the velocities horizontal and the vertical component of the velocity. So by using the 22 meter per second and 40 degree, we can find the horizontal and the vertical component of the velocity. So the horizontal component would be, so since it is a right angle triangle, so the horizontal side is cos and the opposite is sine. So horizontal is 22 sine 40 and opposite is 22. Horizontal is, that is the adjacent is 22 cos 40 and the opposite is 22 sine 40. So the opposite is 22 sine 40. So we break the velocity into its component. Then the wall is horizontal. The wall is a horizontal distance of 36 meter from where the student releases the ball. So the distance from the wall to the student is given as 36 meter. Here resistance is negligible. That means as the ball is moving, there is no air resistance opposing its motion. So there is no air resistance. Determine the time taken for the ball to reach the wall. So we need to find the value of time for the ball to reach the wall. So to find the value of time, so we have given the value of velocity. So we know the value of distance, that are the distance values. So we can use the formula velocity is equal to displacement by time. So velocity is equal to displacement by time. So the value of time is equal to displacement by velocity. So time is equal to displacement by velocity. And to find the value of time, so here we have given the value of horizontal distance. So the horizontal distance is 36 meter. So we can use the horizontal distance and the horizontal velocity to solve this problem. So the horizontal distance is 36 meter and the horizontal component of the velocity, that is horizontal component of this velocity, is 22 cos 40. So 22 cos 40. So by substituting the value, we find the value of time, that is 2.136, that is approximately 2.1 to two significant figures. Then calculate the vertical component u of the initial velocity of the ball. So what is the vertical component? So for the vertical component, we know that by using the right angle triangle, cos theta is equal to, so vertical component. So vertical component is sine. So sine theta, let's consider the angle as theta. So sine theta is equal to opposite, it is opposite by hypotenuse. So we need to find this opposite side. So opposite side is equal to sine theta into hypotenuse. So the value of hypotenuse, this is the hypotenuse, that is 22. So the hypotenuse is 22 and sine theta. So we have given the value of theta as 40. So sine 40. That means our opposite side, or this side, there is the vertical component of the velocity, is 22 sine 40. So the vertical component of velocity is 22 sine 40. And if we just calculate, then it will be 14.14, that is approximately 14 meter per second. Then the ball just goes over the wall. Calculate the height of the wall. So the ball goes over the wall. So the ball goes above the wall, over the wall. So the ball goes just over the wall. That means from this point. So we can say that the height from where the ball goes is approximately equal to the height of the wall, because it is given in the diagram, that is they are equal. So how can we find the value of height? So we can use a distance formula, that is S is equal to ut plus half at square. So by using this formula we can solve this problem. And so for this part, I want to add something that we can use S is equal to ut plus half at square in this formula also. But here we can see that we know the value of initial speed, that is the initial speed, that is 22 cos 40. So 22 cos 40, and the value of, so we know the value of distance, so we need to find the value of time. So the time is t, and we have given the value of distance, that is 36 meter. So this is 36 meter, and we have the horizontal velocity as 22 cos 40. So horizontal velocity is 22 cos 40 into time plus half at square, and here we can use this formula also, and it would give the same answer as given, because here acceleration is 0. Why acceleration is 0? Because in the horizontal direction, suppose for the ball moving in the horizontal direction, so the ball is moving in the horizontal direction and there is no force opposing the horizontal direction, because the air resistance is negligible. Since the air resistance is negligible, so there is no opposing force in the horizontal direction. So since there is no opposing force, so the horizontal velocity remains the same. Since the horizontal velocity remains the same, so the acceleration is 0. That means in the horizontal direction, since there is no force acting in the horizontal direction, suppose the ball for this point, so there is no forward force at this point. For example, the ball at this point, the ball is already being thrown. So the ball is thrown from this point, and now the ball is at this point, and the ball is already being thrown. So now at this point there is no forward force acting on the ball, because it is already being thrown. Since there is no forward force acting on the ball, also since air resistance is negligible, so there is no backward force. There is no forward force acting at this point, and there is no backward force acting on the ball. So the resultant force in the horizontal direction is 0. And since the resultant force in the horizontal direction is 0, so acceleration is also 0. So acceleration is 0. After substituting the value, we can calculate the value of time as 2.1. Now for this part, that is the height. So S is equal to ut plus half at square. So now we need to calculate the value of vertical height. So for the vertical height, there is this vertical height. So we need to consider the vertical component of velocity, and the height is h, and the time taken to reach the wall is 2.1 second. So from this second to this wall, whether in the horizontal direction or in the vertical direction, the time is same. That is, from this point to this point, the time taken is 2.1 second. So we know the value of time, we consider the height as h, and we know the vertical component of velocity, that is 22 sine 40. So S is equal to ut plus half at square, where the initial component of velocity, that is the value of u, is 22 sine 40, and 22 sine 40 is 14. So 14, and the time is 2.1 second. So the value of time to reach the wall is 2.1 second. So ut plus half at square. So what is the value of acceleration? Now for this ball in the vertical direction, so for the ball in the vertical direction, we know that the weight is acting vertically downward. And for air resistance, since air resistance is negligible, so there is no other force that is acting in the vertical direction. So only weight is acting, and since only weight is acting, so weight is equal to mass into acceleration. So here the acceleration is acting is the gravitational field strength. So gravitational field strength, and the gravitational field strength downward is 9.81 meter per second square, and for upward movement, it is negative 9.81 meter per second square. Since here we can see that the ball is moving from this point to upward, since the ball is moving upward, so the acceleration is negative 9.81. So we need to consider acceleration as negative 9.81, and after substituting these values, we calculate the value of distance, that is S is equal to 7.8 meter. Now we calculate the distance as 7.8 meter, and this distance is from this point. So from this point to this point, that is from this point to this point, the vertical distance. And sorry. So from this point to this point, the vertical distance. So this vertical distance, and we need to find the total height. So the total height is this vertical distance plus 1.2 meter. So this vertical distance plus 1.2 meter, because we calculate the height from the initial position to the final position, that is, this is the initial position and this is the final position. So we calculate this value of height, and the total height, that is h, is equal to this value of height plus this value of height, that is 1.2 meter. So we need to add 1.2 from this value. We need to add 1.2 with this value to calculate the total height as 9.0 meter, that is 1 2. So it is two significant figure.